Okay, here I'm going to explain proof by contradiction, where the given statement is for every integer n, if n square is odd, then n is odd. So in this case, what is p? P is this, n square is odd, and n is odd, it is q. N square is odd, whereas q is n is odd. Now in a hypothesis, we should assume that p conditional q itself is false. It means that p is false and q is true. Have I written it correctly?
No, sir.
Yes, I have written it in the reverse order. That is, here p is true and q is false. So this statement is wrong and this is correct. Then only this p conditional q is going to be false. So let me write, whenever we have p as 1, q as 0, then only result is going to be 0 in case of conditional. So p must be true and q must be false, so that our result itself is false. So we are assuming that the result p conditional q as false, so p is true and q is false. Well, now let us consider in case of analysis that q is false. What is q? Q is, sorry, n is odd. When it is false, n is not odd. That is, it is even. Well, so n is equal to 2 into k I can write. Am I right? Well, now let us take n square. N square is equal to 2k whole square. Now it will be 4k square, and it will be 2 into 2k square. Now n square is even. That is, here we are proving that n square is even. But what we have assumed? We assumed that this p is true. Yes, we have assumed that p is true, and now we have proved that this p is false. Now this contradicts. So what we have assumed is wrong. We had assumed that p as true and q as false. So that itself is false, means the given conditional p conditional q is true by proof of contradiction.